Hello student, myself Digan Sakhiwala, I am your science sir. Today we will continue chapter number 4, the structure of atom. Dear student, initially J.J. Thomson gave the model of the atom, but in that some drawbacks were there, as well as Rutherford gave the model, and according to that the positively charged particles are the center and electrons moving around the nucleus, but it has also some limitation. So Niels Bohr gave the model, in that most of the drawback of the Thomson model and the Rutherford model was corrected. Okay, so we will learn about the Bohr's model. Okay, Bohr's model of an atom. In order to overcome the objection raised against the Rutherford's model of the atom, Niels Bohr put forward the following postulate about the model of an atom. So dear student, take care that here the one word is written here, postulate. It is just postulate, because proof of this thing, electron, proton and neutron, is difficult to get. Okay, how they are rotated around the nucleus and all. Only certain special orbits known as the discrete orbit of electrons are allowed inside the atom. So electrons are moving in the different type of orbits. Okay, and because of that reason, what happened? It will not radiate the energy. So according to Rutherford model, that electrons are always moving in the circular path. So what is the limitation of circular path? When it moves in the circular path, and automatically it undergoes the acceleration motion, and because of that reason it emits the energy. So as it emits the energy, it is going nearer to the nucleus and finally drop into the nucleus, but it is not possible like that, though no matter is stable. Okay, so its solution is given by the Bohr, that all the electrons are moving in the discrete type of orbit. Now dear student, orbit is also called cell, or sometime it is also used the word as energy state. Okay, so n equals to 1, that is called the K cell, or it is called orbit, first orbit, or it is called the first energy state. Like that, L, that is n equals to 2, this is called the second energy state, second orbit. Okay, the sub part of the orbit is called orbital, that we will learn here. Okay, only certain special orbit known as the discrete orbits of electrons are allowed inside the atom. While revolving in discrete orbits, the electron do not radiate the energy. So when electrons are moving in the different type of orbit, okay, n equals to 1, that is K, n equals to 2, that is called L, n equals to 3, that is called M. Okay, so in that, whenever they revolve around the nucleus, at that time it will not emit any type of energy. These orbit or cell are called the energy level. So these orbit or cells are called the energy level. Okay, these orbit or cells are represented by the letters K, L, M, N, or number n equals to 1, 2, 3, 4. So higher standard you come to know that they are also known as the principal quantum number. Now no need to remember this thing, just you remember that n equals to 1, that is the called K cell or K energy level, n equals to 2, that is called L cell or L energy level, n equals to 3, that is called M. Like that we can represent the energy state, orbit and the cell. Neutrons. In 1932, James Chadwick discovered another subatomic particle which had no charge and a mass nearly equal to that of the proton. Okay, so in the nucleus, not only the proton is present, but the neutron is also present. Okay, with the proton, neutron is also present. Now the question is arise that if in the nucleus only protons are present, then what happens? Repulsion is possible between two proton and two proton. Okay, so why the repulsion not occur? Because the neutron is act as a cementing agent, it holds the two proton together. Okay, and because of that reason the repulsion not occur. And it was discovered by James Chadwick in 1932. It was equally named as neutron. Neutrons are present in the nucleus of all atoms except hydrogen. Okay, so neutron is present in all the type of atom. Okay, exception is what? Hydrogen, normal hydrogen. Now dear student, hydrogen has three isotopes: normal hydrogen, deuterium and tritium. So normal hydrogen, in that neutron is not present, but deuterium and tritium in that the neutron is present. In general, a neutron is represented as n. Here we can see that here the neutron is represented by the small n. The neutron has no charge, so it is written as n. The mass of an atom is therefore given by the sum of the mass of the protons and neutrons present in the nucleus. So whenever we have to calculate the mass of any atom, then we have to calculate mass of proton plus mass of neutron plus mass of electron, but we are not measuring the, or we are avoiding the mass of electron. Only reason is that the mass of the electron is negligible. Okay, mass of the electron is what? Negligible. We can compare the weight of our hair and weight of our body. In that weight of hair we avoid it, like that electron is present in the atom, so weight of the atom is depend upon the number of proton and number of neutron. Now when we compare the weight of the electron and proton and neutron, then weight of the proton is 1836 times more than the electron, and weight of the neutron is 1838 times more than the neutron. Electron distributed in the different orbit. Now dear student, here we have another concept will come, that is called orbital. Okay, so electron distributed in the different orbit. Like we have one school is that is called atom. Okay, you consider the one big school, that is called atom. In this school different standards are there, they are called orbit. Okay, and you can see that in the different divisions are there, like 10G, 10th H, 9G, 9th H, they are called the orbitals, and electrons are student here. Okay, so we can say that in the atom electron revolve around the nucleus, that is called orbit, and the sub part of the orbit is called the orbitals. So here we have 4 orbitals are there: s orbital, p orbital, d orbital, and the f orbital. For that you will learn in the higher standard. Okay, in the 11th standard generally you will learn about that. The distribution of electron into different orbit of an atom was suggested by the Bohr and Bury. So Neil Bohr, Rutherford, they were the student of J.J. Thomson. Okay, so how the electrons are arranged in the atom and orbit, that is suggested by the Bohr and Bury. The following rules are followed for the writing the number of electrons in the different energy level or the cell. So how to write the electron, or how the electrons are arranged in the atom, okay, or orbits. So we have to follow some rule. First, the maximum number of electron present in a cell is given by the formula 2n square. Okay, so number of electron present in the orbit, that we can find by the formula 2n square, where n is the orbit number or energy level index. Okay, so number of electron present in the orbit, like first orbit is called k, second orbit is called l, third orbit is called the m. So we will use the formula 2n square. By the formula 2n square we can find out the number of electrons. So here we have the formula, that is 2n square. In that we will put n equals to 1. So we get that in the first orbit or first energy state or first cell, in that 2 electrons are present, n equals to 2, that is the second orbit or the L cell or the second energy state. In that 2 into 2 square we are adding n equals to 2, so we get 8 electrons. N equals to 3, that is called the M cell, M energy state, okay, or the third orbit. In that 18 electrons are possible. So you have to remember the formula 2n square. By that way we can find the number of electron in the different orbit or cell or the energy state, and they are represented by K, L and M. Now dear students, something extra that you will learn, that is the number of orbitals. Okay, some reference book maybe it is given here. Number of orbitals we can find by the formula n square. So number of orbitals we can find by the formula n square. So first orbit we can say that if we are adding n equals to 1 here, then in the first orbit only one orbital is present, so it is represented by 1s. S means spherical. Okay, so this we can find here. All this thing you will learn in the higher standard. Okay, but just you come to know about this thing, then it is easy for you. Same way, whenever n equals to 2 in the L cell, L orbit, or the we can set energy level, in that 8 electrons are present. Now in that orbit we are writing 2 square, that is 4, means 4 orbitals are present, that is 2s, 2px, 2py and 2pz. 1, 2, 3 and 4 orbitals are present. So electrons are moving in the 2s, 2px, 2py and 2pz. N equals to 3, that is the M cell, third orbit or third energy state. In that 18 electrons are possible. In number of orbitals are 9. You can see that 3s, 3px, 3py, 3pz. 3dxy, 3dyz, 3dzx, 3dx square minus y square, and 3dz square. Here the x, y, z, they indicate what? Direction. Okay, on x-axis, y-axis, between the x and y, then it is called xy. Like that we can write. If you count, then total 9 orbitals are there. 1, 2, 3, 4, 5, 6, 7, 8, and 9. The maximum number of electrons that can be accommodated in the outermost orbit, 8. Okay, so number of electron present in the outermost orbit is what? 8 here. Okay, suppose 18 are there, then how we are writing? 2, 8, 8. So again the 8 will come, 18 we are in then. So outermost orbit contain maximum number of electrons are 8. Helium or hydrogen, they have the 1 and 2 electron in outermost orbit. Electrons are not accommodated in the given cell unless the inner cells are filled. Okay, so electrons are not accommodated in a given cell unless the inner cells are filled. Okay, so we can see that electron first enter into the first orbit, first energy state. If the then it is over, then it enter into the second energy level or second orbit, second cell, or in the L cell, and then after step by step it enter into the n equals to 3. So electron enter into first into 1s, 2s, 2px, 2py, 2pz, 3s, 3px, 3py, 3pz, 3dxy, 3dyz, 3dzx, 3dx square minus y square, 3dz square. Like that it enter into 4. So electron enters step by step. Now dear student, we are going to learn about the electronic arrangement. Okay, how electrons are arranged into the different atoms. So we take the example of hydrogen. Hydrogen atomic number is 1. So here only 1 electron is present in the 1s orbit here. Lithium atomic number is 3. So we can write 2, 1 because first orbit has capacity of 2 electron. And the second orbit has capacity of 8 electrons. So 3 electrons are there. So we can write 2, 1. Beryllium, we can say that 4 atomic number. First orbit has capacity of 2 electron and second orbit has 8 electron capacity. But we have to arrange 4 electrons. So we are writing 2, 2. So now it is become a 4. Boron, atomic number is 5. We can write 2, 3 here. Okay, because second orbit has capacity of 8 electron. Carbon, we can write 2, 4. Atomic number is 6. Nitrogen, atomic number is 7. So we can write 2, 5. Oxygen atomic number is 8. We can write 2, 6. Fluorine atomic number is 2, 7 because atomic number is 9. Neon atomic number is 10. So we can write 2, 8. Now you can see that second orbit has capacity of 8 electron. It is filled up here in the case of neon. Now next orbit in that, next atom in that, electrons are enter into the new orbit, new energy state or new cell. So you can see that sodium is 11. First orbit has capacity of 2 electron. So here we are writing 2. Second orbit has capacity of 8 electrons. So we are writing 8. Now we have to arrange 11 electron, but here we already filled 2 and 8. Third orbit has capacity of how many electron? 18 electrons. So electron now enter into the third orbit. So 2, 8, 1 we are writing. We are not writing here 2 and 9. Understand? Because second orbit has capacity of 8 electron. We cannot write 2 and 9. Or we cannot write here 3 and 8 because first orbit has capacity of 2 electron. Same way magnesium, first orbit has 2 capacity. So we are writing 2. Second orbit has capacity 8. So 2 plus 8, 10. And now how many electrons are remaining? 2. And third orbit has 18 electrons. So we are writing 2, 8 and 2. Same way aluminium. Aluminium is 13. So what we can write here? Aluminium first orbit has capacity of 2 electron. Second orbit has capacity of 8 electron. So 10. And aluminium is 13. So 10 and 13. So last orbit in that 3 electrons are there. Silicon has atomic number 14. So we can write 2, 8, 4. Phosphorus atomic number is 15. So we can write 2, 8, 5. Sulfur atomic number is 16. So we can write first orbit has capacity 2 electron. Second orbit has capacity 8 electrons. So 10. And third orbit has capacity 18 electron. But here 16 electron are there. So 2, 8 and 6. Chlorine is 17. So first orbit has capacity of 2 electrons. Second orbit has capacity of 8 electron. And last orbit has 18 electron capacity. But chlorine is 17. So 2 plus 8 is 10. And chlorine is 17. So last orbit in that 7 electrons are there. And same way argon is 18. That is the inert gas. So we can write 2, 8 and 8. So you can see here neon, argon, Neon and argon, they are called the inert gas because their outermost orbit contain 88 electron. They have neither tendency to lose the electron or gain the electron, so they don't make any type of compound. Helium is atomic number is 2, so it not complete a octet, but it complete the doublet. Okay, so today we learn about the Bohr's model, we learn about the neutron and how electron distribution occur in the atom.